Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into an 11th grade topic, multiplying complex numbers. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Senpai and tell me all about it there. At the end of the video, I'll be linking my 11th grade playlist, in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash subscribe, and let's get started. In today's video, we're going to be covering how to multiply complex numbers. In fact, I'm going to give you 2 different methods on how to tackle this example here. But before we get into that, there's some necessary components that we have to cover first. Without these, multiplying these complex numbers will be a little bit difficult. In my previous videos, we covered imaginary numbers, we've covered complex numbers, and we've even talked about how to add your complex numbers. Now, if you hadn't seen any of those videos and you have questions on those topics, you can find them right up here. However, in those videos, we know how to multiply our imaginary numbers. We talked about that. So if we were to get something like I times I, we know how to handle that. This I times I is going to be I squared. Now, we already know how to simplify this as well because of I's special properties. Your imaginary numbers have special properties in which they repeat themselves as you get higher and higher values for your power here. So we know that this is going to simplify to -1, but we know that it doesn't matter what power you have, you'll be able to simplify it down to your first 4 powers of I. So multiplying imaginary numbers is something that we've covered already. And when we added complex numbers, we even talked about how to multiply constants times imaginary numbers. So if we multiply something like 8 times I, we know that that's simply just going to be 8i. You put it together, 8i, that's what you get. And of course, if this was I cubed, you would do that, and then you would simplify this to just be -8i. Once again, simplify your i's at all times. But this is all stuff that we've talked about. And by extension, because you know how to do both of these, you would know how to do something, let's say, like this. If we had a 6i times a 7i. If we had 6i times 7i, we know how we would do this if we were to combine both of the 2 things we just talked about. Well, you have this times that, so what's 6 times 7? That will give you your 42, and then you would have I times I, which is going to give you your I squared. And of course, your I squared should always simplify, so I squared is -1, so this is actually going to equal -42. So multiplying imaginary numbers times imaginary numbers, we know how to do that. Constants times imaginary numbers, we know how to do that. And even if you had a constant times an imaginary number times another constant times an imaginary number, you should know how to do that as well. But these are going to be the components that are going to be necessary in order to multiply your complex numbers. So now that we've covered those, let's jump into our first method of multiplying our complex numbers. So our first method that we're going to cover is what I would call the distribution method. Now, I call this the distribution method because it's going to look and feel just like how we distributed our constants. So when we had something like 3 times 2 plus 8i, we said that we had to distribute this 3 to both components. Well, we're going to do the same exact thing, but instead of distributing a constant, we're going to distribute the entire complex number. And when we do that, we're going to get something like this. So 2 plus I is going to distribute to both of these. So this is going to distribute to this and to this. So you're going to have 5 times our complex number, 2 plus I, minus 3i times our complex number, 2 plus I. So we've distributed our entire complex number to the components of this complex number. And the result is more distribution is necessary. But we're going to distribute a constant this time and an imaginary number this time. So let's do that. Let's simplify this to get rid of our parentheses by distributing everything. So this is going to be 5 times 2. It gives us a 10. We're going to do to that and to that. So 5 times I is plus 5i. This is going to distribute to this and to that. So this is going to be a negative 3 times 2 is going to give you a negative 6i, right? Bring your I there. And a negative 3i times I is going to give you a negative 3i squared. Now always simplify your i's as much as possible. You can't simplify that one, but you can simplify this. I squared is just going to be negative 1. We have a negative here, so the negatives are going to cancel out, giving you a positive. So this I squared is going to go away because it's a negative 1 times that negative 3, giving you a positive 3 here. Now that we've simplified all of our i's and we've gotten rid of all of our parentheses, we can just combine our like terms. So we have a 10 plus 3 gives us a 13, and we have a 5i minus 6i, which gives us a negative I. So our final answer is just going to be 13 minus I. And notice all we did was do the distribution method that we're so used to with constants. But instead of having a constant, we had a complex number. But it's the same exact steps. So now we're going to move on to our second method of multiplying our complex numbers. But we're going to stick with this example because we want to make sure that we get the same exact answer no matter how we do it. So our second method that we're going to be talking about today is going to be our FOIL method. Now the FOIL method is something that we should know and love by this time. You've been using it ever since you had to multiply your binomials, and it's going to work the same exact way when you're using them on complex numbers. And by this time we know that the FOIL stands for first, outer, inner, last. That means that we're going to multiply your first, your outer, your inner, and your last. So let's get started by focusing on our first. Our first is going to be this 2 times that 5 here. And when you do 2 times 5, you're going to get a 10. So that's going to be our first. Our outer is going to be this 2 times a negative 3i. 2 times negative 3i is going to be what? Well, 2 times negative 3 is going to be a negative 6, and you just take that I with you. So a negative 6i is going to be your outer. Your inner is going to be this I times 5. Well, what's 5 times I, or I times 5? Well, we know that to be our 5i. That's going to be our inner. And our last is going to be this I times our negative 3i. And our negative 3i times I is going to result in a negative 3i squared. That's going to be our last. And of course, we should always, always, always simplify your i's when possible. We can't do these, but we can do this one. And this is going to be a negative 1 times a negative 3 here. So the resulting L is in fact a positive 3. Now that we've simplified all of these and we've removed all of our parentheses, we can combine our like terms. So we have a 10 and we have a 3 here. So what's that going to be? We have 10 plus 3 is going to be a 13. And we have a negative 6i with a positive 5i. Well, that's going to give us a negative I here. So when we combine everything, our final answer is going to be 13 minus I. And notice, this is the same exact answer we got when we did it the other way, our distribution method. This shows us that it doesn't matter which method you choose, as long as you do it properly, you'll get the same answer. So if you're more familiar with FOIL because you've been doing it for a while, or maybe distribution stands out a little bit more to you, just choose what you're most comfortable with and do it properly. Well, I hope you were able to follow in today's video and help you know how you can multiply your complex numbers. However, if you have any questions about what you saw today or even on homework, remember you can put it in the comment box below or visit my Facebook page at Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Senpai.